Hello everyone, this is Amir from Audio Science Review. Got a request to test power cables, and I remembered that I had bought this AudioQuest cable for testing about a year ago. It's the NRG-X3. I think they go to Y and past that. The version that I bought is a 2-meter length, and it costs about $100. You can see my order from Amazon here. So as aftermarket cables go, is quite inexpensive, although, you know, the free cable comes with the equipment, so compared to that, it's infinitely more expensive. The one thing I was disappointed to see for a company the size of AudioQuest is that there's no regulatory safety certifications on this. In US, that would be UL, and it could be the CE or CSA regulations and certification. None of that is on this. So US, maybe you can get away with because UL is not mandatory, but for Europe, CE certification, CE compliance, at least, is mandatory. Otherwise, you can't export the product. And I looked on the box even everywhere. I looked on their website. There's no mention whatsoever of anything related to that. The only thing I see on the cable is actually their own brand. And it only says, oh, I guess it does have temperature rating. It's 16 gauges and 300 volts, 75 degrees C. But you know, no certification for the cabling or termination. Now, looking at it, there's nothing that worries me, but, you know, those safety standards are there for a reason. And, you know, you want to have the peace of mind that something plugs into electricity, you know, that deals with high currents and high voltages, that, you know, it doesn't have any safety risks of this thing, for example, getting hot and catching on fire or something of the sort. So, is it going to happen? Who knows? But, you know, my little cheap generic AC cord that I use has UL listing on both the wire and the end of it. So the end terminal is plugged in down there. I'm not going to get it, but at the, you know, right even inside here has a UL stamp on it, and it has it on its wire, and it goes way past that and saying what kind of jacket it has and so forth. So a big miss. You know, I can see somebody making cables in their garage not being able to afford to pay a lab to do this kind of testing, but to see a company like AudioQuest that sells millions of dollars worth of cables wouldn't have $5,000 to go spend to get that regulatory certification is just disappointing. On a positive front, the cable itself feels better than a generic mains cable that you get. I don't think it's silicone, which is one of my favorites, but much more expensive. But it's something halfway between the PVC jackets and silicone as far as flexibility. It feels good. The ends look kind of dorky to me. This thing looks like maybe something out of 1960s plug for I don't know, hot water kettle or something. It doesn't look fancy, doesn't look high-end, and the whole cable doesn't look fancy or high-end. So that's typically something that you get, and it's sort of an unwritten rule that if you're going to be in the cable business, you dress up the cable as much as you can because, you know, other benefits may be hard to prove, but the look could be it. But anyway, it is what it is. So let's move on. I was delighted to read the feature list, Bluetooth feature list on their website, and notice this thing that says it minimizes distortion. I hadn't seen that claim before. Everybody talks about what the copper is made out of and everything, but it says it minimizes distortion caused by grain boundary that exists within any metal container. So nice thing, so I'm delighted is that, you know, you talk about distortion, we can measure distortion. You talk about, I don't know, adds air to your music, that you know, I may not be able to measure, but I sure as heck can measure distortion. It also says it gets rid of, it has noise dissipation technology, whatever that means, and but we can test that also. So both of those are quantifiable characteristics. Now, what's a little silly is that let's say this thing does have special material in it that doesn't add distortion, but, you know, you got hundreds of feet of cable behind your socket and then outside your building that you can't even control. Surely if cable adds distortion per foot, then having, you know, hundreds and you know, thousands of feet of meters of any generic cable will dwarf anything that a 6-foot cable could add. So the logic of this makes no sense, that this This, you would care about this part of it not having distortion, where, if every cable has distortion, then, any system you use without this cable should sound awful, which we know that's not the case. But anyway, we take these things at face value. If we wanted to reason through this thing, we wouldn't even test it. But we want to prove to ourselves that we know what the benefits are or not. Speaking of which, I started with measuring DC resistance. These things can get hooked up to a power amplifier, and we want to know whether they have extra resistance to flow of electricity in there. And my generic cable, which I just randomly picked, had a 0.13 ohm DC resistance, and this one was much better, 0.02 ohm. So about 10%, 15% of that, so quite a bit better in that regard. Part of it may be the quality of the leads in here, or the pins on the AC outlet. They're some kind of, I don't think they're gold, but some kind of coating on them, silver coating on them, and they feel nice. And the generic one, of course, the standard sort of nickel plating or whatever they have. So maybe I wasn't getting as good of a connection. Again, this is not material, because your socket in your AC outlet and then all the wires behind it have many times this kind of impedance, kind of DC resistance. So your total DC resistance is not, this versus this is, I don't know, 0.8 ohms compared to 0.078 ohms. So again, in grand scheme of things, doesn't matter. But, I think it's fair to give credit where it's due. And, I was surprised how good this was. That only has 20 milliohms of resistance. So every time I do tests like this, where you could just, declare the thing useless, I actually sit back and I say, all right, what can I do different to test these products in a more creative way and try to probe and find out what's going on. In this case, they talked about distortion. I said, I've never measured the distortion in a AC power cord. Let's see if we can measure that. So I set up my audio precision analyzer, programmed it to produce 20 volts, which is near its maximum output, as a substitute for 120 volt. And then I told it to produce 60 hertz, which is the main frequency we have. And then I told the audio precision to short its input to its output. So it's measuring itself. So it's generating 60 hertz, high quality 60 hertz. And then it's measuring its own distortion and noise. And as you can see, it's just got impeccable specs. Despite this voltage being quite high, 20 volts, is able to still keep distortion down. SINAD is 120 dB, so it's extremely good response. But again, this is no wire at all. This is the input and output shorted with a relay internally to audio precision. I then measured my generic cord, power cord, same way. What I did was that I want to make sure this testing is clear. I took a generic, the AC cord, and treated it as a signal cable. So it's hooked up to the input and output of the analyzer. It's not powering the analyzer. It's not powering anything. But it's being driven. Think of this as the most pure AC signal you can get compared to your regular AC, which has tons of distortion and noise. This AC is 20 volts, lower than mains, but exceptionally clean with this kind of noise and distortion. And so I run that through it, and if AudioQuest is right that regular cable has distortion, then we should be able to see it, right? Because we're just, cable doesn't know that you're hooking up to mains or whatever. Anything goes in, comes out. If those crystals have friction and cause distortion, we should be able to see it in this test. But we do not. The performance is the same. It's remarkable that a AC cable, a generic one at 2 meters, acts almost as if you have no cable. It's got that high of a fidelity with a SINAD of 120 dB. Yeah, a little bit more distortion, and this would come and go. If I sat there, it would drift up and drift down. So it's not a perfect cable, but even if we take the worst case thing, the peak is minus 130 dB. So your regular generic freebie cable is that pure that it could be used as the signal cable for very, very high performance applications, let alone for mains where it's just carrying juice to your equipment. So, but let's switch now to the AudioQuest NRG-X3, and we see the same thing. These things were again dancing up and down, so I wouldn't go by exact value of them, but essentially the performance is the same. Same SINAD, same distortion, same 20 volts, and same 60 hertz. So the claim that this thing has lower distortion, I mean, we're measuring down to minus 160 decibel, and we're still not seeing any claims of, you know, it producing less distortion and or the regular generic freebie cable having any source of distortion. They're imagining problems and stating them as proof. If they had proof, they should measure it and showed us what distortion there is with a generic cable versus their cable. If they don't know how to measure distortion, then they don't know that it has less distortion, and they shouldn't advertise that. So on distortion front, it's a complete bust. Regular cable is phenomenally good. Why? Because the cable length is short. You know, 6 feet is not that long of a cable, and you can drive pretty good signal quality through that length of cable. Okay, so now somebody may say, whoa, you just measured the, you know, audio frequencies, and in this test ends at 22 kilohertz. Well, that's all we can hear. But, you know, for grins and let's go ahead and test the maximum bandwidth of my analyzer, which is 1.2 megahertz. So now we're going 1,200 kilohertz. You know, something like 60 times higher than threshold of hearing. And look over here, the two look identical. Yeah, there's little variations here and there, you know, with NRG actually looking a little worse, but that's just run-to-run variations. We see there, you know, few interference spikes in the cable, same in both of them. So it's down to the most minute signature of the signal. They're identical. Neither one of them is showing anything, any distortion products way past here that is not in the other one. It's the same characteristics in both cables, down to minus 130 dB. So you just can't make a claim that this one cable is better than the other one based on noise and distortion, both of which are being measured in here. So that's a bust as well. Now, the other test I usually run is to see how susceptible cables are to picking up interference, magnetic interference. In this case, it's a silly test in that if these cables pick up 60 hertz, that's the power you actually want to produce. So, but you can think of it in reverse, in that if I can induce 60 hertz and harmonics into a cable, that means it can also radiate 60 hertz just as well. So I set up the audio precision analyzer this time to generate 1 kilohertz, just to have a signal that is not 60 hertz so we can see the contributions. So first I started with a generic cable, and I took a transformer. It's the transformer from my linear power supply that powers my Grass instrument that I use for headphone measurements, powers this preamplifier. So I set up a constant situation where the cable was draped the same way, and I put the cable transformer on it and wiggled it around till I got the worst case interference with the generic cable, and the worst case is minus 130 dB for 60 hertz. Then it's got the third harmonic and so on that's just, you know, going out past that. Then I did the same thing with AudioQuest NRG-3, and you can see the signatures the same. So yes, I had to wait, you know, place it a little differently than I did with this one because the geometry of the cable and jacketing is different. But you can see that I was able to induce similar kind of interference. So as far as I'm concerned, both of them generate the same kind of interference pattern. And keep your signal cables away from it or across at 90 degrees. In general, but you know, are these audible? No. Even in the worst case situation, the peaks are at minus 125 dB. So even if this was coming out of your speaker, you wouldn't hear it. In this case, is the AC cable having to go inside the equipment, which then filters it anyway. So not a concern, but again, you know, a bust as far as showing that the AudioQuest is better cable. Now, all of this was sort of appetizer for the real test, which is, you know, again, as I keep saying, like a broken record, you don't listen to an AC cable, AC signal, you listen to an audio equipment. So let's see if the audio equipment, you know, performance changes. I just measured this Top-In DX5. It has an internal power supply, so I thought, what the heck, I'll just use this as a random example, not anything handpicked. And our first measure is performance, and it's as good as I reported a few days ago. So its distortion products are less than minus 130 dB. You know, you can see such small details here. We're able to pick up little spikes in here down to minus 150 dB. It's just incredible amount of resolution our measurements have, and we still can't see. We can't see any contribution from mains. Look how clean the mains response is in here. There's none of that, the interference that I showed you. But maybe this gets cleaner if we power it with the AudioQuest cable. And of course, it does not. Same two distortion spikes are generated by the DAC, and the same little wiggling tiny bits of distortion are here. They're all functions of the device itself. And again, nothing, disturb as far as mains is concerned. So everything else is identical. Yes, there's a little bit of run-to-run variations, and that's normal. If I just watch the device with one set of cables, this decimal place changes a little bit on this thing. So using a low-power device that's probably less than 50 watts or less than even 20 watts, the DAC doesn't care. So your source component, generic cable, just as good as anything else. But, let's see if there's any contributions from that slightly lower DC resistance, and maybe it carries more power. So I just tested this Audiophonics stereo amplifier as well. And I went ahead and retested that with the generic cable and then with the AudioQuest cable. And look at these two graphs. I mean, they couldn't land on top of each other any better. They're just identical amount of power, identical amount of distortion, identical amount of noise. And we're measuring very deep in here, minus 115 dB. And so if there was a hair out of place, we'd see the difference. And we absolutely are not seeing a difference. The power amplifier one did not produce more power. Again, that's the reason for that. Simple, you got all the other wires behind your socket, and at any rate, this, you don't need that kind of ampicity, as we call it, out of a cable. So in every direction we're probing, we're seeing that just it all points to the same reliable outcome that we could have predicted. We could have just said it and declared it and walked away. Why did I go spend the $100 and run all these measurements? It's because it's good to have data. You could say it, but the other side said, whoa, there's some EMI problems, or one leaks more magnetic field, and maybe one has better resistance to this and that. So we measured all of that. Next time somebody says, whoa, these aftermarket cables, sounded better because of this and this and that, the manufacturer says, we've proven that the manufacturer's feature list is bogus. If they're not bogus, they should have been backed with measurements. And if they weren't before, here's an invitation for AudioQuest to show us how they measured noise and distortion. I'm happy to see that. I'm happy to go replicate what they've done and measure it. Now, stepping back, though, it's easy to just be critical of this thing, but other than the ugliness of the ends on this thing, it is a flexible cable. It feels good, and $100 not a lot of money. I mean, it's like go to fast food place 4 times. So if you bought something that costs $100 and you use it and feels good every time you touch it, fine. I mean, it's just you buying it for other reasons, which is better feeling, and I wish it was better looking also. It's not, but it feels better. It has a lower resistance. The connectors actually mating is pretty good. So it has attributes that you could choose that it's worth $100. So in this case, it's hard to just be overly critical. Would I go buy it? Would I use this right now? I still wouldn't use it. I'm use the generic cables that everybody else has. And by the way, once or twice I've gone to, I had some issues, and I was like, oh, I wonder if this solves it. Nothing. I was getting some noise once, and I, on a whim, I said, well, let me try this. I had some mains noise on an analyzer, and I put this in there, made no difference at all. I used another aftermarket cable. I have no difference at all. Turned out to be something silly that I fixed. But it's, you didn't break the bank. Now, the problem is that this company makes much more expensive cables, going to tens of thousands of dollars, I think. Power cables, I think, $20,000, $30,000. And if this is their reasoning to make those kinds of cables, and these are the benefits they talk about, then it brings to doubt the merits of those cables. I hope somebody sends them to me for testing. I love you guys, but not any more than $100 of my own money to go waste on cables like this. And, shows that we're sincere about this, that I do go spend my own money, buy this stuff, get real data, and find out if they do some good. Before somebody said, did you go listen to it? Yeah, I could listen and tell you some random stuff about, whether I heard a difference or didn't hear a difference. Know that that's just not the way the world turns. When I show you signals that are below threshold of hearing, the measurements sometimes speak the truth and say it so strongly that you just don't dare saying, well, maybe it's still like, no. When I'm showing you measurements with noise and distortion, they're just incredibly low. And the engineering principle behind it is says you can't make a difference. The fact that in a sighted test, I could tell you it made a difference or didn't make a difference, it has no value. A blind test where you get a dozen people and run them through a trial 10 or 12 times would be useful. So anybody who says this stuff doesn't count, go ahead and do that blind test, turn on your camera on your phone, and go ahead and record and produce that video and show it to us. The manufacturers have never produced such a test. No user that raves about these cables has done that. Yet it's very simple, right? You don't need me. You don't need my instrumentation. You don't need knowledge of measurements. You take one cable, plug it in, and then plug in the other one and randomize that sequence and make sure the person listening can't tell the difference. Do it 10 times. Might say, oh, maybe I'll get stressed and I can't hear it. Well, then that means the difference must be tiny. And it's certainly not this kind of difference. Look at what the guy at Stereophile talked about. Let me, it got a little big. A reviewer that said the NRG-3 delivered more music. Well, there's no such thing as more music, right? You can right away say this is nonsense. And then he says, made more sense of the music. How do you make more sense of music? These are not technical terms. These are not proper descriptors for fidelity. And then it says, managed to fully convey artist's intentions. Well, you don't know artist's intentions. You just listen to a recording. What the heck do you know about artist's intention? Did you call them up? Did you send them the cable? This is all made up, almost like a robot wrote these things, except it is a reviewer at Stereophile. And unlike most of the reviews that has the measurement section, so we could sanity check it, this one did not have a measurement section. So why didn't it have a measurement section? If the measurements are no good for this, how come they're good for something else? So, this is how this stuff is sold. And, any logical person should step back and say, that's not it. This stuff doesn't make any sense. How would an AC cable have control over any of these attributes at all anyway? If it lowered the noise, let's hear it. Lower the noise and we can measure that. Lower the distortion, okay, we can measure that. But don't feed me stuff like this in your conclusion. That just makes no sense at all on this thing. Okay, so whoever asked for this review, hopefully is satisfied. I have another after-market cable, a Pangea, that I can test. A little bit more expensive and much heavier duty than this. I can test, so maybe I'll do that in a future video. But for now, please don't buy these cables because they think they make your equipment have higher fidelity. They cannot, they do not, and there's no existence proof for such. Okay, see you in a future video. Bye-bye.